And welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Tonight we'll be looking at Plotly as a way of data visualization, and we'll be doing it in Google Colab, and hopefully this session will be suitable for beginners. It's a live stream, so you can ask questions. I'll be watching on Google Chat and also on our Slack channel. So if you need to join the Slack channel, there's instructions there about sending an email to pieskyproject@gmail.com, and we'll get you onto that. If you want to post messages, use the Learning to Code channel as part of Beginners Python. And we'll see, hello Scott, and Slade's also waved, so very good. We've got a couple of people there already. Fantastic. Okay, so this is an online session, and our next in-person session is on September the 27th, and that will be at Brisbane Business Hub on the Queen Street Mall in Brisbane. And really like to see you there if you can turn up. There's pizza, free pizza, and we've got Alex Stenlake will be doing a talk on setting up your Python environment and using PyEnv and Git, and a lot of those tools that you need to know if you want to do some Python coding. Alright, but tonight we're going to be using Google Colab, so that you don't need to install Python on your computer. You just need a web connection and hopefully a Google account. Now if you look, this is the meetup description. Also below the video in the comments, there should also be a link to the Google Colab notebook. And so if you click on that link, that'll take you off to Google Colab, and where Google will kindly give us a virtual server each that we can play with and run. So this one, for some reason it's connecting, but I don't need it to do that. This one here is what I've created for you. But at the moment you won't be able to make any changes to it that you can save. You can run it, but you won't be able to make changes. So what I recommend is clicking copy to drive, and that'll copy it to your Google Drive, and from there you'll be able to make changes and really just play around with it, and that's what the beauty of Google Colab is. So I've made a copy as well because I'm running in a different account here. And I might I'll share my copy just in case that anything that I type might you'll be able to use this share link and grab it without having to try to copy it straight off the video. But I recommend that you create your own copy and try to follow along and do stuff for yourself, because that's the way that you really learn. So I'll copy that link and I'll post it into here. And there we go, it's on Slack as well. Alright. Okay, now the way you run Google Colab, first of all, you hit on connect, and that way Google will allocate you some RAM and some drive space to store all our stuff. And then it's just a Jupyter notebook, which is a form of Python. It's pretty close to straight Python. It's called, but it's got a few extras included. So it's actually IPython, or interactive Python, that it's running here. It runs in a series of cells. In each cell you can put code or text. Just if I hover between the two cells, I can add a new code cell or a new text cell. This top one is just a formatted text cell, and this one below is a code cell. So we can't run the text cells; they're just for reading. But the code cells we can run them, and so they get a play button at the beginning, which we can play to run it. Now, in these cells we normally put Python, but as the Jupyter Notebook gives us extra features, if we start our Python lines with an exclamation mark, it means we can actually run command line tools such as pip, which is the Python, the package installer, and we can see whether Plotly is currently installed for us. So if you're doing this from your own command line and not using Google Colab and not using Jupyter Notebooks, you wouldn't put the exclamation mark there. You just type pip list and you get a list of all the packages that have been installed as part of what you've got. And normally in a straight Python installation you won't have very many, but Google Colab gives you pretty much everything that's in Anaconda, and so it's quite a long list. So I've piped that through to grep Plotly, which just filters the list down to only show me Plotly, and we've got Plotly version 5.15 installed, so that's really good enough. Some of the exercises needed 4.5 or later, so we don't need to do anything. If you wanted to, if you don't have it, you can do pip install Plotly, and if you've got Plotly, an old version, you can do pip install -- upgrade Plotly. Okay, so let's get into doing some Python. We're going to be using these third-party libraries. So we're going to be using NumPy, pandas, and Plotly. So most people, when they use NumPy, they import NumPy as NP just to save on typing. So that's like an alias. Whenever they want to use NumPy, they just say NP dot and then whatever they want. And similarly, pandas is normally imported as PD. And then we're going to import Plotly, and as well as Plotly, we're going to import Plotly graph objects as GO and Plotly Express as PX. So run that cell, it'll get a number to say that we've run it. So it's number 2. Okay, so what is Plotly? I've given you a link here, and there's quite a lot to Plotly, so don't feel that you should try to remember everything that's going on here. Really what you're doing is you're looking at what's available for you to use, so that you know in the documentation where to look for stuff and what is actually possible. Now I'll try to explain the concepts behind Plotly, and once you understand what's going on, it makes it a lot easier to know how to make changes and manipulate it and for your own purposes. And your own purposes might be, you're writing a web application and you want to show some graphs in that, or you might want to save a file, an HTML file that's got all the Plotly interactiveness built into it, or you might want to take a screenshot of the graphs that Plotly produces. So what Plotly really is, plotly.py is really the library, so that's the Python library, py for Python, for sending JSON objects, which is the JavaScript object notation, off to plotly.js. So plotly.js is what runs in your web browser. Unfortunately, we're in a web browser here, so it's a great place to see this stuff. And the JavaScript does some amazing things. The Python library itself is not actually doing a lot. All it is doing is sending it's just creating a dictionary that gets converted to JSON and sends that off to plotly.js, and then gets plotly.js to do all the work. So here's an example of a dictionary that we've created. So it's in curly braces here, so that says we're creating a dictionary with keys and values. The first key is data, the second key is layout, and in that data's a list of other dictionaries. In this case, it's we're doing a few bits of data that we want to a couple of series of data that we want to display, and each one of those is a dictionary with a type saying we want to do scatter graphs. They'll have x coordinates, y coordinates, and we'll even give them a name for the legends. And then there's some extra stuff about the chart to do with layout, such as what the title is going to be. Alright, so that's just a dictionary. There's nothing special about that, but we can run this command plotly.io.show on that dictionary, and it will convert it into a chart for us. Now if you're not using interactive Python, you can create an HTML file and this is the way that you will do that. Now I'll just do it once here. I won't be doing that for the rest of this session, but I'll show you that it's possible, so that where we're doing show, you can do write HTML if that's the environment that you're working in. So let's run this and see what we get. And there's our Plotly chart. So it's a scatter chart, which is what we expected. We've got the X values 1, 2, 3 for the up-down curve. So I just called it up-down because it goes up and then down. And the other curve I've called climber because it goes up and keeps going up. Now I can hover over any of these points and you can see the coordinates that are there. So it's a really nice feature. We've got a legend. We've got blue as our up-down curve and red is our climber. We've got a title here, scatter chart constructed as dict, and that's what we told it we wanted the title to be. You see, if I hover over the chart, it produces this menu of other things that we can do. So we can zoom in, which is the standard functionality we're on, but we can also pan or select, lasso, zoom in, zoom out, auto scale and reset. Or if you want to download a plot as a PNG, just click the camera button there. Alright, so let's play around with zooming. So you can zoom, I can drag straight down to zoom in vertically like that, or I can drag straight across to zoom in horizontally like that, or I can choose a rectangle, and so that's when I'm not going straight across or straight up and down, I'm going down on a diagonal, and then now I can zoom in on both horizontally and vertically. Alright, now if I wanted to pan, I click on pan up here, and now my mouse cursor becomes the arrows, and I can click and drag the graph around to see all parts of it. I can click on minus to zoom out. Auto scale, what's that? Just takes me back to that. Or I can do reset axes, which is how it was originally. Okay, and you might want to know, have a look at this fig1.html. And so if you see over here in Google Colab, there's a folder here called Files, and in that you'll see we've created this file called fig1.html, and you can click on the triple dots to download it if you want and have a look inside that. I won't be doing that, and you'll see that there's really quite a lot of JavaScript code in there and just a little bit of data. Okay, so I like to set challenges here. I've even left a blank box here for you to do it, so you can see the challenge. Given the following list of x and y values, which represent a sigmoid function, plot the values in a scatter chart using a dictionary. Okay, so we'll run that because that'll will populate our data, and you can see x, we've used numpy, so np dot linspace to create an array that's got linearly spaced all the numbers from -10 to 10, and we wanted 21 numbers, so that's gone up in integers, so that's quite useful. And then y, this is a really clever thing that NumPy can do. We've just put in the one formula, but because it recognizes that x is an array, then -x will make a negative of all those numbers, and then np.exp will apply the exponent function to every value of x, and all of this, then adds it to 1, but that adds every value to 1, and then takes the reciprocal of that and every single value and creates a y, which is also an array of values. Okay, so we've got our x and our y. Let's make them into a dictionary and plot the values. Well, I like copying and pasting, so I'm just going to go up to here and copy and paste. And we're only doing a single chart, so we'll get rid of that one. The X values are already in a variable, so rather than type them all out there, I'll just type X, and for Y I'll just do Y, and the name I'll just say sigmoid. And well, I don't even really need to give it a title. So let's see what happens when I do that. And there's my function, nicely plotted. And see, I can hover over each of those values in our sigmoid function. So remember, sigmoid, it's a useful one when you're doing your machine learning. Okay. Now, I provided the solution here. And so, yeah, we'll notice we didn't get a legend when we did it. So the trick here is if you're only showing one item in a data list, you need to explicitly show the legend. So we've got show legend as true. Name, we gave it a name. So let's run this and see if it shows the legend. And it does. Sigmoid's over there. It's got a proper title, and everything else is the same. Okay, so that's pretty low level. We're just creating dictionaries. Yeah, that'll work. You can definitely do it that way. And if you understand the schema of the dictionary, then you can just do them always in that way. But now we'll start looking at Plotly graph objects, which we've imported as GO, and show a different way of creating really the same dictionary. So in graph objects, we have these different classes. Like figure, we'll create a figure that we can then show, just like we did. That figure is a dictionary. This one is actually a figure, and we can print the figure to see what the dictionary inside it is. It's using a graph object bar, which creates these things, and you think, well, what's the advantage in doing this? Like, we still need to know the schema of putting everything. Well, the advantage is that there's a little bit more error checking going on in the first place. So for example, if I got this wrong, rather than saying show legend, I said show legends equals true, and I tried running this, I'm going to get an error message, and I'll just scroll to the top because it's quite a long, there we go, there's our error message. And it says, on this line I've got a problem, and the problem is this: invalid property specified for object of type bar, and as I've said, show legends. So it doesn't know what show legends is. So that's the mistake, and I can correct that by saying show legend. In fact, it even suggested down here, did you mean show legend? So that was pretty clever. And it gave a list of all the different functions that I could have used, or the different parameter names that I could have used, and show legend is one of them. Okay, so let's run this now using go figure and go bar and go layout, and see how it looks. This time we've got a bar chart, so something slightly different. We can hover over it. It tells us what the coordinates are for each of those. So that's x of 3, y of 2, and it's got a legend there, blue boxes. All right, as I promised before, we can see how graph objects has converted our objects into a dictionary, and there it is there. Looks pretty similar to before, name, show legend, type, x coordinates, y coordinates. And then for layout, it's got this template in there which we didn't use before, and Plotly adds that template in even when we were doing the low level one, but you can override any part of that if you want. If you want to see what's included in template, it's quite enormous. So this is how to convert config to a real dictionary if you really wanted that dictionary. And here you can see all the stuff that's in our template in layout. So we've got all the standard stuff, and then everything else is in the template. So there's quite a lot, all just different colors and things to set things up. All right. Okay, challenge 2, using X and Y from challenge 1, plot the values using graph objects. Okay, so that should be pretty simple. Let's copy and paste. So rather than a bar, we'll want a scatter diagram. We'll use the X that's in the array variable X. We'll use Y, which is in the variable Y, and we'll call it sigmoid. What happened there? My mouse. There we go. We'll call it sigmoid, and we'll show the legend, and we'll change that to a scatter chart. We don't need to save the HTML, but we'll show it. Alright, scatter chart created using graph objects. We've got our legend, sigmoid, so that was pretty easy. Probably same level of difficulty as before, but we did already have the layout, all the schema there, so it wasn't too hard. Okay, so let's have a look at the solution. And the solution is the same. It's just added a couple more features in there to so that we can see how things affect. So it's got things like marker line width. It's got marker symbol in there. And we'll have a look at the dictionary that it creates, and it's got a little note here saying check what happens with marker line width. So here it's got specified as 1. So let's run this. Here's our dictionary, and we see there isn't actually in our data anything to do with marker line width, but there is a marker dictionary, and inside that there's a line dictionary, and inside that there's a width dictionary, and inside that there's a 1. So this is the thing that Plotly does, is that if you use an argument name and separated by underscores, it will use that to make it traverse through the levels of dictionaries to create. So we don't have to say marker equals. We could do it if we wanted, but we don't need to do it. We can just say marker line width equals 1, and it will work out all this traversing to put it in the right spot. Similarly, marker symbol equals hash dot, so we've got marker there and symbol there. Now this is not a Python thing, this is a Plotly thing, so don't expect it to happen on any other Python libraries, but it certainly happens in Plotly, and they've got really a unique case for why they need to do this, because otherwise it would just get too complicated. Alright, and there is what it looks like, and we've got all the symbols here, and they're like hashes with the dots in them, and there's our legend. Alright, so what other marker symbols are available? Well, Plotly hides a lot of data in its library as well. So if we go into the Plotly library, we go .validators.scatter.marker.symbol validator.values, we can see what the names of all the different sorts of markers are that we can use. So let's just run that and see what that looks like. Okay, so here's our symbols. So it's stored in our variable raw symbols. So you have to look at these in groups of 3. So we've got a circle, open, we've got a circle dot. And then if we want to refer to these, we can refer to them by these integers. So 0 if we want circles, or we could just use the name. And so you can see we've got the stem of the type of marker is circle, but there's 3 sorts of it, or 4 sorts actually. So we've got the circle with an being open, we've got a circle with a dot in the middle, and we've got a circle with open and a dot. Alright, and then it goes to square, square open, square dot. Alright, so challenge 3. I've said here a challenge. This is more Python than Plotly, but it's an interesting little puzzle here. How do we get this raw symbols list into something that we can use a bit more easily? And what we want to do, we want to create tuples. We want to have the integer value, we want to have the string value in the tuple, and we want to have the name, the stem, which is in this, all these first 4 cases is circle, and then we want the variant. So the first variant is nothing, then we've got dash open, dash dot, dash open dot, and then we repeat the whole thing for square, square open, square dot. Okay. So let's just look straight to the solution, and then we'll go back and have a look at it, think of another way of doing that. Once again, this is just Python, but it's a fun little Python challenge to do. So we'll create a list of group symbols, and then we'll loop through our raw symbols going up in steps of 3, because there's 3 in each group here. We'll get the integer value of the ID, the string value of the ID, and the name. And in Python you can actually do 3 assignment statements all on the one line, so make your code a little bit shorter. I'm not sure it makes it clearer, but short code's always good code. So that takes raw symbols I, that takes raw symbols I plus 1, and that takes raw symbols I plus 2. So that's going to be I plus 1, I plus 2, I plus 1, I plus 2, I plus 1, I plus 2. Okay, and it's going to store them into int ID, string ID, name. Then once we've got the name, we have to work out what, if it's got any variance, and what the stem is. So I was thinking, you could look up the dash and see where the location of that is in the string, and then take what's before the dash as the name stem, and what's after it as the variant. But it turns out that we've got some things like triangle up open, so they're using dashes within the name stem as well. So really we have to know that the variants are always open dot and open dot, and then just find any stems what are left after we take them away. So to take them away, we just take the name, we replace any instances of dash open with an empty string, and any instances of dash dot with an empty string, and what we're left with is the stem of the name. And then to find the variant, we just look at the name and we do a slice. So the colon is the way for doing string slices, and we want to start after we've taken the length of the name, so after we've taken triangle up, and just take all the characters that are after that, so dash open, dash dot, or dash open dot, and store that into name variant. And then on our list we can just build this up one by one. We can append our int IDs, string IDs, name stems, and name variants, and we get all our group symbols. So that's one way of doing it. Has anyone thought of another way of doing this? I might I'll show you a way that I thought of doing this. So remember how you can use string slicing with this colon. You can also do list slicing the same way. So for example, I could say I want my list of all the integer IDs is going to be all my raw symbols, and then slice it, and I'm going to start from 0. I'm going to go right up to the end, and I'm going to go up in steps of 3. So let's have a look at what that gives me. And it prints it all on one line, so I want it printed all on one line, I mean. There are my integer IDs. So it's got 0, 100, 200, 300, then 1, 101, 201. So if we look here, that's what we get. So that's put all our integer IDs into one list, and then we can do the same for all the string IDs if we really wanted them. But this time, rather than starting from the 0th element, we'll start from the 1 element, go all the way to the end up in steps of 3, and we'll print that. Same thing, that one worked, and we can get all the names. And these ones start from the 2nd element, go to the end, up in steps of 3, and we run it. Okay, so now we need to get the stems and the variants. For that we can use list comprehension. And to do list comprehension, we use the square brackets, and we'll say S, and this is where we just get rid of all the opens and dots. Using the same technique as before. And where do the S's come from? They're just every item in our names list. Okay, so let's print name stems. And yeah, we've got to say what we're replacing dot with. And so there's our name stem: circle, 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 square, 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 diamond, 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 diamond. So there are our name stems. The name variants is a little bit harder. So let's do one for that. So for name variants, we use list comprehension, and this time we're going to use pretty much the same as we did in our loop solution. So we'll look at our names list and take out the ith element, and from that we're going to slice it using our length from our name stems list. Once again, the element I of that, and remember to put in the slicing colon for I in range length of names. And so here we should have nothing, open dot, nothing, open dot, nothing, open dot, open dot. All right, so we've managed to split them all up just using list comprehensions and slicing. So that was a lot of fun as a solution for challenge 3. Now challenge 4, how would we sort? Actually we haven't got it into a tuple. We haven't got a list of tuples yet. So now to put it into a list of tuples, we can say, I'll just call it group symbols equals, I'll call it properly. we use the zip function, which is a standard built-in function of Python, and it just so it's not zip like compression, it's zip like how the teeth of a zip work in your clothing, and it goes it just oscillates between two teeth, but you can actually oscillate between several different things. So we're going to oscillate between our int IDs, our string IDs, our name stems, and our name variants. And remember, this is what we're trying to get down below here. So we've got a tuple here, which is int ID, string ID, name stem, name variant. Then the next one, int ID, string ID, name stem, name variant. And that we can create a zip to do that, and we want to then convert that into a list. So we put it into the list function, and then let's print that. Now I don't have a zip function in any other language that I program in, so I don't often think of using it. So I was pleased that I actually thought of it in this case, and there we go. We've got it's zipped up. It takes the first element from each of those lists and puts them in a tuple. Then it takes the second element from each of those lists and puts them in another tuple, and there it's all created. And that's actually what we wanted. So that's our solution to challenge 3. Now, solution challenge 4, sort those tuples, list of tuples by name. And so name is the so the index, we refer to that by index 2 out of each of the tuples. And so I'll just show you how we do this. I just look at the solution. So group symbols dot sort, and the key equals, we create this lambda function. We could have created a named function, but we'll just do an anonymous function here. And for each tuple, sort on the value at item 2, which will be circles. So this will put all our circles together, and then it'll put all our well, in fact, it'll put the symbols that have got the earlier in the alphabetical order, like arrows, they'll be before circles, etc. And then once we've got that, then we can split these up into separate lists, which we've really done already, but they weren't sorted, but this will have them sorted. So let's just run the solution, and here we go. So let's put all the arrows at the beginning in our group symbols by using that sort function, and then we can just pull out the stems, the variants, the symbols, and the numbers for the symbols. And the reason we're doing this is we're going to try to create a bit of documentation to help us find all the different symbols, what they look like, and how we would refer to them. So that's our challenge 5. I'm just going to run through the solution because it's really the answer is more interesting than trying to find the answer. So for our x values, in fact, we'll just run the solution so you can see what the output is. And here we go. So our x is the name variance. So remember, that's just the dash open, the dash dot, and the dash open dot. So that's what is showing on our x-axis. And the y is the name stems. So that's your main part of the name. So arrow, arrow bar down, arrow bar left, arrow bar right. So now we can see all the different symbols that we can use. Some of them have got 4 different variants, others have just got 2, and so we can use them. So that's the cross. That one name is cross open, and that one's cross with a dot, and this is cross open with a dot. So you can just see what they look like and go through this whole table and choose which one. And this is actually a chart. It's a Plotly chart. but we're using it to, draw it like a table. So I quite like that. Okay, so let's look at Plotly Express now. So it's an even higher level API. It's more designed for data exploration. It uses DataFrames, so if you're using pandas DataFrames, then you've got your data already in a form that's going to be useful for Plotly Express. So that's when you would use it. So let's create a couple of DataFrames here and see what we can do with Plotly Express. So remember, we imported plotly.express as px, and we'll create a couple of DataFrames here, and we'll then use Plotly Express. We'll take the data frame. So we're going to take two data frames, join them together to make one. Let's have a look at it. There's our data frame. It's got a column ID, column score, and we've got a column called group that just says whether it's in the up-down group or in the climber group. And then we've passed the data frame to Plotly Express, said we want a line diagram. We've told Plotly Express to get the X values out of the ID column, the Y values from the score column, and the color from the group column. Now, color is a weird way of saying how they want the legend to be used, but anyway, I guess each one of those is a different color, so that's what they're doing. So we're saying our different members on the legend are up, down, and climber, just as before, and it's got all that information from the data frame. So that's quite an easy way, if your data is in a data frame, for plotting it. Okay, using X and Y from challenge 1, plot the values using Plotly Express. Okay, so let's have a go at that. We've got to create a data frame, and I can never remember how to do this, but let's see. We can pass in attributes like data equals Y. The index for the data frame is going to be X, and the names for all the columns in our data frame. There's only one column, so we'll call it sigmoid. Alright, then we'll create a Plotly Express line chart from that, and remember we've just have to provide, say which we have to give it the data frame, tell it what the X, Y and color is going to be. So the data frame is just df, the X is going to be the index, in fact I think it'll just use the index by default. So the Y is going to be the sigmoid column that we've chosen, and that'll do. So it's used our index as our X values and the sigmoid column as the Y values. Let's have a look at the solution here. In the solution we've created an extra column called function, and that one we've just put the name sigmoid everywhere on every line of that, and we'll use that to do a legend because we haven't got a legend here. So let's see how that works. You can see function equals sigmoid just on every one of those. So if we had different values in there, then we'd get two lines showing and a separate legend out here. Okay, let's have a look at some more data. Now Plotly Express actually comes with some default data sets if you want to practice. I think that's really nice. So they got one called Gapminder, which is all about the life expectancies of people. I'm not sure why it's called Gapminder. So px.data is part of the Plotly Express library that just contains data, and the Gapminder is a particular set of data, and then we just want to filter that down a little bit so it's not so much data, and so we just look at the continent Oceania, which is Australia and New Zealand, and then we'll plot the years, the year that it happens and what the life expectancy was in that year, and separate the legend out by country, and we'll show that. So you can see that in the early years New Zealand had a higher life expectancy than Australia, but now Australia has got a higher life expectancy than New Zealand, and it's got some quite nice hovering there. It tells you country, year and life expectancy when you hover over any point. And this is all the data. There's well over 1,000 data points in the full data that they gave us, so that's quite a good way of getting some sample data if you want to play with doing some charts. Okay, I've given you a link here of where you can look at other chart types, but I'll play with a couple here. So one I'm going to look at is the Sankey diagram. This is quite a nice one. So just using graph objects, we do the graph object.sankey for all this data that's provided, and this is showing data going from one and where it gets split up. So this is showing a taxation breakdown, and you can even do things on this chart. It's just amazing. Like you can drag different parts around. Like even if I drag this one down, it can rearrange it over any of these. So it's amazing, and then you can reset it back to the original if you like. Here's the a 3D chart. So it's using the isosurface chart type, and so we've got a function here, x, y, and z, and there's the chart that it produces, and this is quite amazing. You can click and drag on it and look at it from all different angles. You can zoom in and rotate, and it's got the different colors for the different values. And that was just using the scroll wheel to zoom in. Notice how surface count equals 3 gets translated into surface, and then a dictionary count 3. That's what Plotly call the magic underscore notation, which we went through before. So if we look at surface count 3, that's the dictionary that got created that gets sent to Plotly JavaScript. Okay. Slade saying the 3D isosurface was the graph from the last session that I completely didn't understand. Okay, so let's have a look at how I haven't actually studied it in too much detail. So we've got 3 axes. We've got an x, a y, and a z. And so for every value of x, y, and z, it calculates a value. But how does it plot that? Because it's already using x, y, and z, the 3 axes, for input data. So the way it works it out is it converts them to colors. And so we're saying we want to split those values into 3 different levels, and I'm pretty sure ISO min and ISO max, that'll be these colors here. So the min color is 10 and the max color is 50, but so it's just saying everywhere that's red, that's 50, everywhere that's blue, that dark blue is 10, and everywhere that's purple, that's in the middle. And so they're the three colors that it's chosen, and it's drawn a surface. It's like a contour surface for that map of x, y, z values that that will all produce that shape, or that value. So if you wanted the equation for a circle, it's not a true function because one x value can have two y values, but it's x squared plus y squared equals your radius squared. So x squared plus y squared equals 16, and that'll draw you a circle in 2 dimensions of with a radius of 4. Well, similarly, you can do a sphere, and a sphere will be x squared plus y squared plus z squared equals a radius, and that radius squared. But what we've done here, it's like a sphere, but it's more an ellipse. So the z values, as well as squaring them, we've multiplied by 2, and the x values, as well as squaring them, we divided by 2. So you'll find that the z values in our isolinear surface should be more compressed, because they have a bigger effect. A little change in z will have a bigger effect on the value, and the x ones will be stretched out. So let's see if we can see that. So if we compare z, which is vertically there, and y, which will be this horizontal one, then you can see the y is not as compressed as the z. And then when we compare y to x, let's see, y to x, and it's a bit hard to see y. Anyway, y to x will show that y is more compressed than the x values. And well, that one we can see z to x. So z to x is that's y down the bottom there. Anyway, I could play around with this for ages. All right. We've done that. Okay, find another example of magic underscore notation that we have used. And the solution, well, we looked at marker line width before, but there's also the layout title text was one that we used before. So let's have a run of that. So layout title text shows that magic underscore notation. All right, now when I was preparing this, I found some of the things that you could do in NumPy, which I wasn't aware of, so I thought, well, I just throw them here so you can play around with them. So remember how we created an evenly spaced array using linspace or arange. So let's have a look at how they come out. So there's 2 different ways. So linspace, we give the minimum, the maximum, and how many different values we want. So that'll take us from -10 to +10, going up in halves, and there's 41 values there. Or we could say we could use arange, which is a bit similar to the Python range function, but Python range only works with integers, so NumPy works with floating point. And that gives us a minimum, a maximum, and a step value. And remember, the maximum values in Python range and in NumPy arange, it goes up to but not including. So we could have said 10.01 or 10.4 there, and we'll go up to 10, but it won't do it won't go any further. If we said 10.5, it would still go up to 10 and not go to 10.5. So that's pretty straightforward. But you can also do this thing in NumPy called a mesh grid. So this is a one-dimensional mesh grid, and you use the slicing notation. So that's just like a range. That gives you the same as a range. So a start, a stop, and a step. But if you wanted to use it mgrid like we did with linspace, which is giving the number of values and not the step of the value, then for the third value you use a complex number. I've never seen this done before, but it's Python can do complex numbers. There's just like a different class like floating point numbers, and they use j's in there, where j is the square root of -1. And they've just said, oh well, we can type that in, so we'll just do 41j as to say that we're using the linspace equivalent rather than 0.5, which is the real component, real number, if we're doing an a range type grid. Okay, create a mesh grid having 3 values. Okay, and I just gave it a little exercise there. And there's the answer, and that's using these complex numbers 3j on each one. And it's really, there's nothing, it doesn't mean anything to do with complex numbers. They're just using that as a way of giving a parameter and so in a really succinct way of doing it. Okay, well that's it for me tonight. I hope you enjoyed it, and if you liked it, subscribe to my videos channel, so you'll be notified when new ones come. And I'd really like to see you at the our next in-person meetup session on the 27th. Next week is the 20th, and Arun will be giving a machine learning one. Let's have a look if we've got what's on the event. So creating serverless APIs will be online next week, and then the following week we're going to be looking at Python, Git, VS Code, PyEnv, Streamlit, and most importantly pizza. So free pizza for anyone who turns up. Okay, I'll see you later.